Hello everyone, I'm Kiko. I come from Group 4 and I'm responsible for the question 4A1 and 4A2 which is come from the semester 1 examination. Now let's take a look at the question first. The R&D manager of a soft drink company investigates the opinion of customers on their new products. In an experiment conducted recently, 18 customers are invited to try a low-glucose herbal tea and 16 of them comment that the level of sweet is acceptable. Construct a 95% confidence interval for the population proportion of customers who accept the level of sweet of a low-glucose herbal tea. To calculate the population proportion, we need to calculate the mean and the standard deviation first. The mean will be equal to 0.8 and the variance will be equal to the square root of 0.8 times 0.2 over 18. We will use this equation to calculate the population proportion, which is 0.8 plus and minus 0.05 over 2 and the square root and times the square root of 0.18 16 over 18. And when we can check from the distribution table, we can know that 0.05 divided by 2 will be equal to 1.96, and finally we can have the answer 0.7123 and 0.8877. Here comes the question A2. The manager would like to estimate the proportion of customers who like the new taste of drink in the next experiment. Determine the sample size such that the error does not exceed 0.08 with at least 95% confidence. We will use this equation to calculate the sample size, which means n will be equal to sample size and e will be equal to the required error of the sample size. N will be estimated as 1.96 square times 1 over 2 times 1 over 2 over 0.08 square, and n will be estimated as 115. Finally, the sample size will be equal to 151. This is the end of my presentation. Thank you.
Hello everybody, my name is Ryan Asim and I'm gonna answer the question 3A.3 of the semester 1 2015-2016. The question is that the customer's waiting time for collecting food and drink at the cafe kiosk follows the normal distribution approximately, with a mean of 4 minutes and a standard deviation of 1.2 minutes. We have to calculate the probability of at least 3 out of 5 random selected customers will have waiting time more than 5 minutes. So first of all, we can say that let x be the event that the waiting of people. So x follows the normal law with a mean of 4 and the standard deviation of 1.2. Then we can calculate the probability that x is higher than 5 with using this formula. Then we can do that and we obtain the result 0.2033 is the probability of the success. The success is waiting more than 5 minutes. So with that we can use the binomial law. So we can say that C follow the binomial law with the n equal 5 and the probability of the success equal 0.2033. So we have to calculate that at least 3 out of 5 people have to wait more than 5 minutes. So then we have to calculate the probability that C is higher or equal than 3. So it equals to the probability that C equals 3 plus the probability that C equals 4 plus the probability that C equals 5. With this formula we can calculate each probabilities and its desk calculus. The result is 0.0605. Thank you.
Hi everyone, my name is Clément Servant. So I'm doing the question Mark 3 for C. So we're looking for an interval of 90% confidence to estimate the population proportion of clerical employees following the flexible scheduling policy. So I'm going to explain my answer. So first, the proportion of employee in the random sample, we have 300 and 500 people. So it makes a proportion of 0.6. Then we can say that the proportion is following a normal law with the following parameters 0.6 and times 1 minus 0.6 on n, and actually it's 500 there. Then we know from the formula that we have this equation, so we can make now our interval. We have 0.6 plus minus 1.645, which is actually the 90% confidence from this table. And then we have here the formula, so just you replace p by 0.6, and q is actually 0.4, 1 minus 0.6, and n 500. And then we can say with a 90% confident interval that the proportion of clerical employees following the flexible scheduling policy is between this interval, so 56.396 and 63.604%. Thank you.
Hello everyone, I'm Liu Tahai Justin. In the following, I'm going to talk about the question for Part B of mock exam 3. And the question is that in evaluating the customer's satisfaction level, a company would like to be 95% confident that the error in estimating the population mean does not exceed 0.05. And the main part of the question is that if the population standard deviation is 0.8, what is the sample size n required? And first of all, we need to assume that the sample is large and normally distributed. And as mentioned in the question, the error does not exceed 0.05. Therefore, we can actually gain this equation like that. And in this equation, there are three unknown numbers: alpha, n, and standard deviation. But mentioned in the question, standard deviation is already given as 0.8. And about the alpha, a company would like to be 95% confident, and it's actually a confident interval. So what we need to do is just to 1 minus 95% to get the alpha as 0.05. And as we have found out the alpha, therefore we can undo this part and as set 0.025. And by using the table of normal distribution, as we have already assumed that it's normally distributed, we can get 1.96. And finally, as we have found out all the unknown number except n, and have already undo this part as 1.96, and therefore we can undo the equation like that. And finally, you can get the n is bigger and equal to 983.4, and therefore the sample size n is actually 984.
Hello everyone, my name is Feng Yingtao, and next I will focus on the question 3b. So let's first look at the question. It is known that 0.01% of people will be affected by a certain infectious disease after vaccination. Among all people having vaccination, 500,000 people are selected at random. Calculate the probability that 51 or 52 people will be affected by the infectious disease. So let x be the probability that 51 or 52 people will be affected. From the question, we know that x follows Poisson distribution, and n equals 500,000, and p equals 0.01% near 0. So it follows Poisson approximation to the binomial distribution. Lambda equals np is 50. So the probability is the probability of 51 people will be affected by the infectious disease plus 52 people will be affected by the infectious disease equals e to the power of negative 51 over multiple 50 to the power of 51 over 51 factorial plus e to the power of negative 50 multiple 50 to the power of 52 over 52 factorial. And the final answer is 0.1083.